Richmond. And please, who was speaking before I left?
Derek, Derek, you can continue.
Akucha, please, I was the one.
Okay, please
Please, my
continue.
battery is
Sorry.
very low. So my battery is very low. So if I happen to go, please can you pardon me? Even you
Okay.
are taking my call since yesterday. So uh, all right. So
Okay.
as I was saying, talking about cryptography, that's one of the techniques for securing information and then communication through the use of code, so that only the party or the information is who is it will get to the said person who is actually supposed to receive the information we are sending via internet. And it also embodies the principles and the techniques for providing data security, including confidentiality and then the integrity of the data we are sending actually. Please kindly go to the next slide for me. Okay. So talking about securing data, encryption is one of the processes we use to secure data by deciphering the data. So then it only can be accessed by the said person we are sending the data to. So encryption is the process of using a code called cipher to turn readable data into unreadable data for another party. The cipher contains both algorithms to encrypt and to decrypt the data. The decryption of the data involves a key that only the owner or the owners have access to encrypt and decrypt the data. And then also we're talking about key. So a key is a series of numbers and letters that the algorithm use to encrypt and decrypt data. It's another way of, you know, preserving your data from unauthorized access or unauthorized use. And then the main goal of encryption is to ensure data's confidentiality. That's to protect your data from unauthorized access. So talking about data protection, what are some of the advantages of encrypting your data? Data protection is one of the advantages of protecting, and encryption is one of the advantages of protecting your data. So encryption helps protect sensitive data from being stolen, read, or altered by unauthorized users. It ensures that only those with the proper encryption key can access the data, making it nearly impossible for cyber criminals to steal or misuse it. Again, it's self-explanatory. Then increase first, is everything okay?
Yes, you can
Increase
go ahead.
consumer trust. Increase consumer trust is also one of the advantages of encryption data protection, in the sense that encryption can boost customers' trust and then confidentiality in organizations by publicly disclosing the use of encryption technology. Probably you want to send an information or data to your client, you have to find a way to preserve it. Like probably, let me say, the hospital. Let's use a hospital as an example. If you want to send a client's or a patient's health information to him via the internet, you can't just send it like that without not protecting the data. You have to make sure it is well protected. That and the third person wouldn't have information or access to the content of it by using it against the patient or something. So we have to find a way to protect it. Is one of the importance of it. Please kindly go to the next slide for me, please. And we're talking about cost. Cost in the sense that encryption can be expensive to implement and maintain, requiring additional resources.
I think he has dropped off just as he said that his device is low. So maybe someone should continue.
Okay, so I'll take off from where Derek ended. We are on disadvantages of encryption. As he said, cost might be a disadvantage as it is expensive to implement some of these encryption methods. And there is another disadvantage, that's key management. Since the key that is shared between both parties, the sender and the receiver, has to be a secret. So if one party breaches that secrecy or that form of keeping the key pair as a secret or safe, it might end up in a wrong hands, and then a wrong person might be able to encrypt their message between them and then their partner. So that's it about key management. There's another problem of compatibility. Okay, so like encryption technology can be very tricky when dealing with them different systems and then applications. So maybe the between the two parties, if you don't have the secret key, you cannot really encrypt any message. If the message even falls into your hands and you don't have the key to encrypt it, or you don't know how to go about the whole procedure, even if you have it, it can be very troublesome to turn the message back into the original form and then make any meanings out of it. Yeah. Please go to the next slide. Okay, so we are talking about the types of encryption that we have. Basically, we have three types: symmetric key encryption, asymmetric key encryption, and then hybrid key. We'll take them one after the other and then look at how they work and all that. Next slide, please. Yes, symmetric key encryption. This type of encryption is very straightforward. I think it's to me, the simplest form of encryption. In this process, both parties use just one key pair or one secret key. So if Perez and I are partners that we communicate or we share information and we use symmetric key encryption method, then we only need one key. If the key is one fruit a day, that is our key. I need that key, and then Perez also needs that line of code or key, one fruit a day, so that anytime I send a message to him in an encrypted form, he will use that same key to decrypt the message and actually read it or make meaning out of it. So symmetric encryption is a simpler type that uses the same key for both parties to encrypt and decrypt. This means that the sender and the recipient must have access to the same key to decrypt the message. Yeah. So next slide. I think you've skipped one. There is one slide before asymmetric. Hello, Richmond. Yeah. So under symmetric encryption, there are types. Symmetric being fast and efficient, and with time, there's been different type of symmetric encryption. As we protect or we provide security or protect our data, hackers are also finding new ways to brute force or to crack our encryption processes or methods. So I think between the types, we have AES, Advanced Encryption Standard, and DES, Data Encryption Standard, and then 3DES. DES, from the history of encryption, DES came first, which was a very strong method of encryption then. But after some time, it was advanced or it was improved on, and 3DES was introduced. Okay, so 3DES is like 3 times the strength of data encryption standard. That's DES. So with this type of encryption, it became harder for attackers or cryptanalysts to actually decipher into our text or our messages. So the hacker that would take few minutes to decrypt a DES method, it would take him 3 times that period. If it is taking you 3 days to decrypt a DES message, it will take the attacker now 3 times 3, that's 9 days to decrypt a 3DES type of encryption. Yeah. And as time went on, 3DES was also improved on, and then AES was introduced. Yeah. Based on history, that is what we have. So symmetric encryption is used for payment applications, to encrypt databases, and then to verify the identity of sender of a message in a messaging application. Please go to the next slide. Okay, so we'll move on to the next or the other type of encryption. That is asymmetric key encryption. Asymmetric key encryption, also known as public key cryptography, uses 2 separate keys for the whole encryption process. So one key is public, and then the other key is private. So unlike symmetric, it's just one key that is shared between the 2 parties. But with asymmetric, the 2 parties have 2 different keys. One is public and the other is private. So like I said, if Perez and I are still communicating, but this time around we are using asymmetric encryption, I need to have my private key and a public key. Perez also has his private key and then a public key. If I want to send a message to Perez, I would have to encrypt the message with Perez's. Perez and I would rather share our public keys, not the private ones. The private ones is to ourselves, but the public key we'll share. Anytime I want to send a message to Perez, I would encrypt the message with his public key. That's the first step. So when the ciphertext gets to him, he will then decrypt the message with his private key, because the keys, the public and private key that we own, they are linked. They correspond. And the same way he sends me his reply, he would encrypt the message he's sending back to me with my public key. When I receive the message, I'll then have to encrypt the message with my private key. Sorry. Yeah. And then that's how asymmetric works. There are two keys playing the role over here. Please, let's move to, okay. So if we compare symmetric and asymmetric type of encryption, we say that symmetric is fast and straightforward because it doesn't require, oh, give me your public key before I can encrypt the message. It is very fast as compared to asymmetric. Asymmetric is complex and time consuming. And with respect to processing speed, symmetric is fast. Even if you are sending large amounts of data, it is very fast because there's no need for me to even ask Perez for anything. I can just encrypt those bulk messages and just send to him. And since he also has the same secret key, he can decrypt the message anytime and make meaning out of it. And with the keys, symmetric uses just one key, a 128 or a 256 bits of keys. Asymmetric uses two keys. Then when it comes to the level of security, symmetric is secure, but there is the risk of compromise in the key that we share, in the sense that if I make a mistake and then I make the key get into the wrong hands, it means that any message that Perez sends to me, that wrong person or unauthorized person who has the secret key can just go straight and then read the messages. The same way, if Perez also makes the key reach a third party, that third party can read all the messages that I share with him. But with asymmetric key, even if I misplace my private key, the intruder can only read messages that Perez sends to me because it needs my private key to encrypt, to decrypt. But the person cannot read any message at all that I have sent to Perez because the person doesn't have Perez's private key. So that's the difference. When we talk about manageability, symmetric encryption becomes complex with more keys. As any time that we might decide to change our secret key because maybe I have misplaced it or Perez has misplaced it, it means that we have to change the key that we use to communicate now and share the new one. But with asymmetric key, it is easy to manage the key system. Symmetric encryption is for there is the security service. The security service that is provided is confidentiality, only confidentiality. With symmetric encryption, when we talk about the security service is only about confidentiality, or it's only confidential in the sense that the key shared is the same key. So if the protection is not that strong, or we don't keep that key very safe or as a secret, it can worry. But with asymmetric, it brings about non-repudiation. I cannot tell Perez that, or I don't have the chance to give him that excuse that the message has been decrypted and I'm not the one. Like, who has your private key? You are the only one who has access to it. That means that maybe my private key has fallen into the wrong hands. And then when it comes to use cases, symmetric is used to securely transmit large amounts of data or encrypt databases. And asymmetric is used for authentication or digital signing or digital signatures. Yeah. Please go to the next slide. Okay. The last encryption method is hybrid encryption. With hybrid encryption, it combines both symmetric and then asymmetric encryption. So even though symmetric has a downside, asymmetric also has a downside. Hybrid takes the good side of symmetric and the good side of asymmetric and combines them. It uses the two. Hybrid encryption is a cryptographic technique that combines symmetric and asymmetric encryption algorithm to make communication or data transmission secure. Symmetric encryption is efficient, whilst asymmetric encryption is convenient. So hybrid encryption combines the strengths of both encryption, both the efficiency from this side and then the conveniency from the other side to create like the whole strong protection thing. Yeah. Please go to the next slide. I think, hello, Richard. Please, we are not seeing your screen again.
Why has it dropped off because of the network? Is that around?
Yeah, so if any of your group members
Sorry,
have decomposed.
I had network issue, sorry.
Okay.
Okay.
I can't see on the screen. You go to where I supposed to take.
Please go to slide 15. Yeah. Okay, so this is a diagram that explains hybrid encryption. Can you go down so that I take the explanation from there? Okay, so hybrid encryption, it works like let me say a three-way handshake. There is the first step that uses symmetric encryption. The second step uses asymmetric. Then the third one uses symmetric again. So symmetric, asymmetric, then back to symmetric encryption. Please, let's take the steps one by one. So the person receiving the message, the receiver, rather creates two encryption keys, a public and then a private key. And then they share the public key with anyone who wants to send them a message, while they keep their private key. The next step, the person sending the message takes the message they want to send and then locks it using a special secret key. So this is where the first locking method happens. The sender would lock the message with the secret key or the symmetric key. And then the sender will use the recipient's public key that they shared with them to then lock the special key. So you are locking the lock, the first lock, something like that, before they send the message across to the receiver. So when the receiver receives the message, pardon?
So you go.
Okay. The sender sends the locked message and the locked secret key to the receiver or recipient. So the recipient also unlocks the first thing, that is unlocking the secret key. So you unlock first one before you get the secret key, and then use the secret key to now unlock the message that the sender has sent to you. So, I think this thing about private and public key thing, I want to use a real life scenario to clarify that. So let's use the mailbox that we see around on the street, or suggestion box at hospitals and places. It is locked. That box is locked. If you have any complaints or you have any letter to send, you just need to know where that box or mailbox or suggestion box is. You just need the location, and then whatever you have, idea or letter, you write it down and just drop it in the mailbox. So it is only the owner that can come and unlock it anytime and collect all the messages that people have dropped, and then they can use the message or read the message. So let's say the suggestion box out there or the mailbox out there on the street is the public key. That one is accessible to anyone. There is no need to protect it giddy giddy like that. So that is something about public key that I wanted to share. Please, let's go to the next slide. Okay. Please, I'll leave it here, and then someone else would continue with us. Thank you.
Okay. Good afternoon to you all, and thank you, Gifty, and for your wonderful presentation. Okay, I will take it from there. So, as what's his name, Richmond was explaining, so now under the data security, we have cryptography, and hashing is also part of the cryptography. And the hashing is a way of scrambling data in a form of, like, the hashing is more or less using a function in order to scramble data, in order to make to make it not readable to unauthorized user. So when you come to hashing, the hashing example, if you hash any character or message, any function you use will scramble the data in a particular number of bits. So when you come to hashing is a one-way encryption. So hashing is always used for one-way encryption, and hash values are very difficult to decode. Hashing is used to ensure data integrity. So hashing is one-way encryption to create a signature of the file. It functions typical standard algorithms such as secure hash algorithm 1. So we have a hash function we call secure hash algorithm 1. People normally call it SHA-1. So the SHA-1 is one of the functions under hashing. So the SHA-1, we have the message digest version 5, which is MD5. So prior to this hash SHA-1 and SHA-5, so the SHA-5 is the SHA-1 is advanced version of MD5, and now there is another a hashing function we call SHA-5 255. That 255 is also more secure than this one, this SHA-1. And there is another one which is SHA-3. The SHA-3 is also more secure than the 253. So now they are even advancing that. So right now you don't have to use the SHA-1 and MD5. So now the recommended hash function to be used is the SHA-5251 and the SHA-3, because these two are modern hashing organism which you can use in order to secure your data. And A hash function generates a unique hash where a message digests from the content of a file or message. Recipient of a file or message can use the hash value to verify that the content has not changed during transit. So that is main function of the hashing. So the hashing is basically you hash the message when it's travel over a network. It ensures that the message has not changed during transit. So we can move to the next slide. So when you come, this is the diagram of the hashing. So you have a plain text. So that plain text will be hashed in the form of a base or anything which make the data unreadable unless you use the hash value in order to uh, uh, decrypt the data back to how it was hashed so that the data will be meaningful to the end user. So I'll end here for my other colleague to continue from there.
Okay, good afternoon to you once again. So, principles of permission. So, first of all, what are permissions? Permissions are basically, we giving access to people or persons to have to have access to our information and our data. Okay, so if we want you to have, let's say, access to a piece of information, or if you are able to access some information, then it simply means that you have granted the permission to these the data or information. So in the definition, we can see that permission is assigned to subject to give the subject the resource access ability defined by the permission, right? And the permission grants a specific type of access to a resource. And yeah, so there are two main types of permissions in data security. We have the discretional access data, where here okay, so the discretional access data where this kind of a permission, a user with some level of access can give a same level of access to can give some can give the same level of access to other users based on their discretions. Okay, then because of how people are easily assigned access to resources, there is this a consistent flow of information across the system, and as a result of that, DACs are very less secured. Okay, please, can we please move on to the next slide? Hello, Richmond.
I think Richmond has dropped off.
Yeah, he has dropped off. Let me see if I can share my screen. Okay, I think he's back. And Richard, please move to slide 19. Slide 21. Slide 21 instead. Slide 21. Okay, so with the as I mentioned earlier on, the discretional access control is a system in which a user with access to a certain level of data can give access to the same level of data to someone else based on their judgment of choice. So as we can see in the diagram below, there is a user who has access to there is an access control down here. But then that same user has also given them like a visitors that same like accessibility power, okay, to also access that same like access, or let's say that same data which the user has, right? So yes, can we move on to the next slide, please? Okay, so just as I also mentioned earlier on, some advantages of this the discretional access control is where managing data and permissions is easier, since the user interface is very easy to operate. There's no need to go through the pain of a planning and everything, or planning everything all at once. Right? Then then also there is just a flexibility in sharing data, since users can actually share, or users can give them like a permissions to other users. Right, so like everyone can have access to what kind of information at any point in time. Okay, then the disadvantages is where we have the less secure system, right? And then here we have that as access can be given from one person to another, data is not well secured under DAC. Thus, it is much more feasible for the administration to overview ACL now and then, which may lead to leakage of information to someone outside the organization. And then also there is a difficulty in keeping track of data or information. Okay, so Yakubu will the work actually to the second type of permission we have over here.
Okay. Thank you very much, Perez. You've said it all, and I will just present the second type, which is the role-based access control. And then before I start with this, I want to describe a scenario. So let's say that if you look at a nightclub, okay, so let's say a nightclub has an age limit, 21 and above. Okay, so if you are not 21 years old and above, you cannot enter the nightclub. So that rule is a permission. Okay, and then let's say at the entrance of the nightclub, we have bouncers. Okay, so they'll look at you, or they'll check an ID, and then if you are not 21, they will not allow you in. So those bouncers are the access controls. So I beg, I know go there before. I just use explain. So and that is just by the way. So for role-based access control, the level of access to a resource is assigned to a role. So that is, permissions are distributed based on roles. Individuals are then assigned to different roles as they need access to resources. So in the Linux course that we did, we have the read, we have the write, and then we have the execute. So the read is 4. The read is given a numerical value of 4. The write numerical value of 2, and then the execute numerical value of 1. So, and if you look at the AWS IAM, instead of you assigning roles to individuals, instead of you assigning permission, instead of you assigning permissions to individual, we assign permissions to roles. So this role-based access control is a typical explanation of the AWS IAM role. So if you look at the diagram that we have in front of us here, we have role 1. So role 1 is having full control of assets 1, 2, and 3. Okay, and then we have role 2. Role 2 has only read and write access to assets 3. So let's say role 1, so let's say role 1 is maybe management. Okay, so maybe the management has access to, let's say asset 1 is maybe finance, asset 2 is human resource, and then asset 3 is, let's say, marketing. So let's say if role 1, so let's say the management will all be put in a single role called role 1, and they will have access to asset 1, asset 2, and asset 3. And then let's say role 2 is the members of the marketing department. So let's say the sales people and then the marketers. And then the asset 3 is, let's say, marketing. So the role-based access control gives control to people or employees based on their job definition in the company. Okay, and let's say, for example, if a new employee comes in, okay, instead of you giving that new employee access to the marketing department, you rather add the new employee to role 2. Okay, you rather add the new employee to role 2, so that the new employee will have access to marketing instead of you giving that role, instead of you giving that permission to that single user. So this is just one of the difference between the first one, which is the discretionary access control, and then the role-based access control. I think Perez has gone off. So I will still continue with the advantages and the disadvantages of the role-based access control. So one of the advantages of the role-based access control is security, improved security. So with the security, it reduces the granting excessive permission to users, which I've just explained, and then it also facilitates compliance with regulatory requirements for adding consistent access, for granting consistent access policies. Okay, and then one disadvantage of the role-based access control is the setup is complexity. So if you don't know the ins and outs of the operating system, and then if you do also the commands, the chill mode and then the chill on, if you don't know these commands, it becomes a little complex, and then it is also inflexible. So these are the main difference between the role-based and then the discretionary-based access control. So this is the end of our presentation, and we will welcome any questions from you guys. Thank you very much. So if you have any questions, your questions are welcome. Thank you.
All right. Thank you, group. Group 4. Okay, so I'm still on the matter of how we can prevent attacks. We just looked at data security, and we looked at the ways or the techniques that we can use to protect our data. So we looked at encryption, we looked at hashing. We said that the encryption helps to ensure the confidentiality of the data, and we saw that cipher is the way that we are able to make readable data into unreadable data, and that for anyone to be able to decrypt or to be able to turn the data back to readable form, the person should have a key. And one of the most widely used key algorithms is the RSA 2048. And I don't know if we took notice of when we were creating the EC2 instance key. So the idea there is that we keep a private key and AWS keeps a public key. And when these two keys are used, we will be able to SSH into our server. So the chances are higher of you getting a system or a device that can decrypt whatever data that it is when you use the RSA 2048. So those of us who took notice of it, the RSA was one of the options when we were creating our key pair. And we also mentioned how important it is to keep to secure our data, because for instance, it could give us financial implications. Some people could even go to jail for leaking data that was not supposed to be leaked, or for people having unauthorized access to data. And we also looked at permissions and how we have the discretionary type of permissions, which in AWS, we could liken to users and groups. So you are able to do certain things based on who you are. And we just opposed it against the role-based approach. And we also said that the role-based approach is dependent on what you have to do. So the only reason why you have that permission is because you have to perform some action that requires that permissions. When it can also be likened to the sudo, how the sudo works when it comes to the Linux root user. You are able to wear the hat, and then after performing whatever function that it is, you put the hat down, and then you no longer have the permissions. So that's also it on role-based approach of assigning permissions. And AWS gives you the chance through IAM to be able to assign permissions based on your needs or based on whatever the user or the role seeks to accomplish. Additional comments about Group 4's presentation. You guys did a really good job. I liked how when Gifty had to move to another slide, she highlighted the main points of the slide she was moving on from. That was good. And yeah, so that's it from me. We would be able to take Group 1 on identity and access management. Group 1, please, are you ready?
Yes, please, we are.
Yeah, we are.
Yes, please, we are.
Please,
Hey,
is your
kindly turn off your
presentation also 1 hour?
Oh, no. We'll be as brief as possible. Not plenty talking.
Because I don't want
Just
it to be rushed. As I said, the idea is that we do not need to go back to reading the slides before we can understand what's going on, or before we can complete cases. But then we also don't want to get into the details too much. So the whole point of your assignment is finding a balance between those two goals that we are trying to achieve. So I don't want it to be rushed, and then it will be like the whole essence of the presentation was not met.
Yeah. Sure.
Okay. So if you say you're ready, then you can go ahead.
Oh yeah. Really?
So
Yeah.
please, before you go on, Dennis, the slide that you had on services. So you had a slide about the services in AWS that we can use to put our security measures in place. And then on the next slide, you had something about best practices. So before you upload your slide to the resources channel, please try to put them together. So I realized that for some of the best practices, the AWS tools that help us do that. So kind of just make those two slides more wholesome. I don't know if you understand what I mean, Dennis.
Yes, I think so.
Okay, thank
I
you.
should just assign the services to the best practices.
Something like that.
Okay.
Okay. Can we start
Okay,
now?
yes, please, good point. You can start.
All right.
So guys, good afternoon.
Good afternoon.
Good
So,
afternoon.
yeah, so we're presenting on identity management. Really?
Yeah.
The word go.
Can you see my screen?
No, not yet.
Yes, Mr.
Yeah, it's visible.
You can see now.
Yeah.
Yes.
Okay.
Okay.
What kind of encryption is going on here?
So can we begin now?
Yeah, we can begin.
Okay, so good afternoon once again. So today we are presenting on identity management. It's also one of the security prevention mechanisms that we are about to talk about. So we'll just explore how effectively managing identities within the AWS is very critical to ensure robust security measures. So these are a table of contents. So we expect that by the end of this short presentation, you'll be able to describe what identity management is, how the authentication works, and also describe the different types of authentication factors that we have, and also certain tools and services that we can support when using this identity management. Is am I clear enough?
Yeah, we can hear you.
Okay, sure.
Yes, it's good.
Okay, all right. So, yeah, okay. So identity management is basically not about just no, go back. Yes, thank you. So identity management is just not about just issuing or giving out usernames and passwords to people just like that. It doesn't work that way. So just ensure that you are controlling the system securely, and it encompasses various processes such as the 3 A's that we talked about: the authentication, authorization, and accounting, which forms the foundation and secure management identity practices. So I beg, please go for it. So this framework will ensure that only authorized individuals have access to the AWS resources that we want to provision. And also, it's crucial for maintaining data security and compliance, and also the regulations. So, so basically what we are trying to talk about is we are just making sure that only authorized people have access to certain permissions and are able to work certain functions on it. So probably some people only have access to just view the resources. Also, some also have access to also do modifications to the resources that they are provisioning. So usually high-end organizations do have such policies in place, especially where organizations where sensitive informations are kept, including like banks and those CIA and those kind of institutions. Yes. So even if you are the president of Ghana, you can't just walk in there and say, oh, because you are the president, I just want to access this information. No, they have certain procedures that you have to follow through. So I think when we get there, I'll take you guys through. Please go for it. So we've gotten to the principles of data management. Please go to the next slide for me. Okay, so yes. So this is where the 3 A's come into play. This one we've already talked about a lot of, so I wouldn't spend much time here. So the first one will be authentication. What is the first step? So authentication basically means proving and validating that you are who you are saying you are. So basically, when that's where, if you have your username and password, to cross-reference with the database in the service. So to compare and see probably if you are saying you are Kofi Edu, then to show that, okay, Kofi Edu, you work in this department, so you're entitled to this. So that's basically what the authentication means. And the next one is authorization. So the authorization that's the stage where after authenticating, it also shows that, okay, so you have the permission to probably rewrite or modify certain resources, or probably you are just able to view or whatever you want to do. So if you're not authorized to probably view or modify certain resources in another department or another resources, you are not able to do them because you don't have the authorization. So that also leads us to our next one, which is the accounting. So the account also establishes auditing measures by logging access commands and changes that users and applications perform. So basically, this thing helps us to probably know who did this at what time, and also helps us when there's any issue or when an issue arises, to help us identify or trace where the fault is coming from, or probably if there was some penetration kind of things entering, unauthorized personnel trying to access some resources. So probably be like, well, okay, so at this point in time, this person tried to access this information or this, then probably we'll see how best we can deal with those kind of issues. Please, the next slide. Okay, I think my colleague will take it from here.
Yeah, so my name is Daniel Asar, and I'll be taking you guys through authentication. So I believe like what Mr. Emmanuel said, authentication is basically, trying to process a person or a system or a person or a system to gain access. So I believe under this particular course, or under this particular program, we are all supposed to be graduates. So in the instance, those times when you're in school, we have the school card. So before you go to school, before you enter the gate to the school or the campus, the security man has to check your ID card to verify whether truly you're a student of maybe University of Ghana or Kia University or any university. The gateman has to verify. That process is called authentication. So he has to authenticate, he has to find out whether truly the card details, the details on your card, it bears your name or it bears your details. So once you have that, then you'll be allowed to go in, which is the authorization. But me, I'll be basing more on the authentication. So please, let's move on to the next slide. The next slide, please. Yeah, so like I said, so for instance, they are saying that we first look at what authentication is. Why? Okay, so just like log in and log out. So in order for you to log into a system, first of all, you need to provide your password and also your email in order to do what? To log in into that particular system. For me, the nature of my job and the way where I work at, usually I work with most of the time we work with national security and also NITA. So most programs being held at maybe, let's say, Accra International Conference Center, most programs we do authentication a lot. We authenticate, so especially high dignitaries are coming, presidents are coming, a lot of big men are coming. So usually what we do is that we have a system that generates, we have a system that people register. After they've registered, that is like registration for the program. After they registered, we provide something like QR code or any encryption. We provide it on the card. When you register, after that, when you come to the event center, we're going to provide you with a card or a tag. Sorry, we're going to provide you with a card, either a card or a tag. So after that has been provided to you, in the card, you are going to have your details, either QR code or whatever it is. NFC or whatever it is, you are going to have it. And this is when you get to the point, there's going to be a checkpoint whereby these national securities are there. They make sure they authenticate. They make sure that your name, it's your name. And also when they verify, they are going to get certain details, which indicates that it's you actually. And I remember some time ago, we had to do this system for MOCD. That's Ministry of Communication Digitalization. And they needed, what's the name? What was it? Was an facial recognition. They needed facial recognition. And I believe all of us know social engineering, and also we know what is called spoofing. So spoofing is like maybe, with facial recognition, you need to, the person has to be, the person has to be present. That's one. Secondly, you are going to have a scan that the person is going to look into, or we are going to have a camera that the person is going to look into. That scans the person's face. And once the person is, authenticated, it authorizes the person to go in or have access to whatever it is. So we were creating a system for them, and we came across this issue with spoofing, whereby so the system basically was about visitor log. So maybe when someone reports to work, they have to, check in first before when they check in, with their face. It has to log in the time they reported, their name, and other details. So in this instance, we realized that most of the staff were using, maybe imagine, I'll be late to work. And I'll ask Mr. Emmanuel, Mr. Emmanuel, I'll be late to work. So this is my picture. So when you get to the place, or when you get to the entrance, they called it e-gate. When you get to the place, make sure you, scan my picture on the system, and that's it. It's authorized, be like, okay, welcome, Mr. Sorry, blah, blah, but it wasn't me. It was just a picture. And that scenario is called spoofing. So spoofing is when someone uses someone's picture to gain access to something. So in that instance, we realized the best alternative was to introduce an algorithm. The name of the algorithm was iBeta. iBeta, I don't know which algorithm that is. iBeta level 2 standards. Good. iBeta level 2 standards. So when you can even go online, and when you are after this course, we can search more about it. It's very helpful. So we had to use an algorithm called the iBeta level 2 standard. And with this algorithm, it was able to detect whether the person was either using a spoofing material, or it was the person's actual face. So in this instance, we made sure the facial recognition was live. So we did something like live detection. So in the instance when you are scanning your face, it has to be live. Like we are able to, it's what I'm talking about is algorithm. I don't want to digress from the main, So we were able to determine whether this face is live or present or it's human. And we were through the algorithm, we were able to catch, or we were able to detect anti-spoofing. We were able to detect spoofing, and that system was very helpful, and it really helped a lot. So that's less I'll say about it. But going for it, I'll be adding more instances and also personal experience. I encountered in the life cycle of software. Authentication, and also authenticating someone, or authorizing someone for a system or something. So going for it, I'll be talking much more about it. So yeah, this is my submission for now. Thank you.
All right. Good afternoon. So I'll be taking the authentication process. So we'll briefly be looking at the three F's, which is the three-factor authentication, which goes a step further than three-factor authentication by adding the biometric elements in the authentication. So we'll first look at the knowledge factor. The knowledge factor requires you to identify yourself through something only you know, such as your password or PIN, in addition to your email, username, or other identifying information. It's the most common identification factor. But one thing about the knowledge factor is for it to be secure, it has to remain a secret. So if you should divulge your password or your PIN to anyone, it no longer becomes secure. And it can be tracked using this force. All right. So we also look at the second factor, which is the second factor for the AFC. In the second factor, we'll be talking about this category involves something the user has, like security tokens or smart cards, mobile phone devices. The second factor adds an extra layer of security beyond password by requiring physical access to a token or device, making unauthorized access more difficult. So that is it for the second factor. We look on the last but not the least, the inherent factor. I think my brother Daniel spoke at length on the inherent factor when he was talking about the arbiter level 2 standard. So the inherent factor is based on something the user is totally known for, or like the person's personally known for. This is the biometric characteristics such as fingerprints, retinal scans, facial facial recognition. Okay, so it provides a strong protection against identity theft and unauthorized access. This authentication factors play a crucial role in verifying the identity of users accessing AWS resources, combining the multiple factor authentication or MFA and security by requiring users. This significantly reduces the risk of unauthorized and strengthens overall security, especially within the AWS environment. So understanding and implementing these authentication factors effectively ensures that sensitive data and resources are protected against potential threats and breaches. So I'll end here and leave the rest to my learning colleagues. Thank you.
Oh, this slide here, one number.
We want to make sure we are within the time frame.
Please who is presenting? Hello,
Hello.
please. Yeah, please who is presenting? Mr. Williams.
Yeah, where's Albert?
No, mine was authentication factor.
Oh, sorry, Edward, sorry.
Edward, yes. I think he's facing issues
So I noticed
joining.
he doesn't come to class for like 2 days now or something. So I actually reached out to him. But was he participating in your group the meetings?
Yeah, he
Yes,
was.
please.
Oh
Yes, yes.
yeah.
And was the last time you guys met?
Oh,
Yesterday.
we met
Okay.
we met yesterday. We met Sunday and also Friday as well.
Because he hasn't been in class in a while. So William or anybody else should take his part.
I'll take it.
Okay. Should I take it or someone going to?
Oh, let me do it. I'll do it.
Yeah, you can go on. You can go on, please.
Okay, so
William.
we're looking at tools and services for identity management in AWS. And right, so first we have the AWS identity and access management. We also have the AWS single sign-on, that's the SSO. We also have AWS directory service and other AWS services. Okay, so when it comes to the identity and access management, it's it enables centralized control over the AWS account user and permissions. Administrators can create and manage user identities, assign fine-grained permissions, and generate access keys for access to AWS services. When we talk about the single sign-on, that's the SSO, um, it simplifies access management across multiple AWS accounts and business applications. It allows users to sign in once using their, let's say, the corporate credentials, and access all assigned accounts and applications without needing to re-enter their credentials. Okay. Um, when we're talking about the directory service, AWS manages the directory services, including the AWS managed Microsoft account and the Amazon Cognito services. Um, these services provide scalable, high available directories to manage user identities, and also they integrate with on-premise Active Directories and other identity systems seamlessly. Is that okay?
Yes.
All right.
And
So
the last one.
other AWS security services. Um, AWS Secret Manager, we have AWS Secret Manager. It enables secure storage and management of secrets such as API keys and passwords. We also have the AWS Certificate Manager that simplifies the process of provisioning, managing, and also deploying SSL, TSL certificates for secure communications and for secure communications, yeah. Okay, so all these tools and services, they form the backbone for identity management within AWS. Um, they also help with addressing various aspects from user authentication and access control to securing of storage for sensitive information. It also allows for seamless integration with existing IT infrastructures. All right. So we're going to move on. We have a case study. We want to show you how AWS identity management works in like a real world scenario. So, imagine you are in a large enterprise environment, and the company you're with uses AWS, and they use AWS identity management and single sign-on. That's the SSO. What this does is it can significantly enhance security and operational efficiency. So, what am I trying to say? So, uh, in a real world scenario, big corporations with various departments and subsidiaries, like a company that has different departments underneath them. Each of them will require access to different AWS resources and applications. So without a centralized identity management and single sign-on, it's going to be challenging to uh, issue out like permissions to different people. So what's the challenge here? The challenge is managing user access across multiple AWS accounts and applications. This becomes complex and time consuming if you have to give access to each person manually. And so we're going to see what we can do to remedy this situation. So by implementing AWS identity management, administrators can centrally manage their user identities, their roles and permissions. They can also create fine-grained policies and dictate who can access which resources. And they can also ensure that the principle of least privilege is enforced. So how are they going to do this? Let's look at the implementation of this. So AWS single sign-on simplifies access management by allowing users to sign in once with their corporate credentials. They can gain automatic access to all assigned AWS accounts and applications without needing separate logins and this will reduce the risk of password-related security incidents and also enhances user productivity. And when you look at all of this, you'd ask yourself, what is the benefit of this? And one benefit of this is that it enhances security through the centralized user management and access control. It also improves compliance with regulatory requirements and reduces administrative overhead. Okay, so users experience seamless access to resources, and it also fosters productivity and collaboration across departments and subsidiaries. All right, so implementing AWS identity management and going hand in hand with single sign-on SSO in this scenario, it demonstrates how AWS identity services streamline access control, strengthen security posture, and optimize operational efficiency within complex organizational structures. So also by using these systems, you can enforce the best security practices in your organization. Okay. Is that okay, or would you want me to go over this? Hello?
Yeah. I think it's fine.
It's fine. Okay.
Yeah,
All right.
yes, please.
So yeah, so I'm going to drop off and let someone else continue for the next ones.
Yes, yes. Mr. Ellis is next. Yeah.
Hello, I hope everyone can hear me clearly.
Yes, please.
All right. Please, next up, we are going to look at the best practices for identity management in AWS. And a brief or simple description of what best practice is a way of doing something that is seen as a very good example of how it should be done and can be copied by others. So basically, it's the most efficient way of applying principles, procedures, frameworks that would produce the best results. Can you give me the next slide, please? All right, so we are going to look at these three main best practices, and the first of which is use of multi-factor authentication, which adds an extra layer of security beyond passwords. So what multi-factor authentication does is it requires users to authenticate using multiple factors. For example, something they are, something they know, something they have. Usually something they know is a password or a code of some sort. Something they have, usually a card or something that verifies their identity into the system. And something they are is usually a biometric factor, fingerprint, iris scanner, among others. So what MFA does is significantly enhances security beyond the traditional password-based authentication. It mitigates the risk of credential theft or compromise, ensuring that only authorized users gain access to AWS services. So when you apply multi-factor authentication, what happens is that in the unfortunate instance of your credentials being compromised by somebody, they would still have an extra layer of security that they will have to get through in order to access your resources. And they will not be able to do that because they do not possess the other authentication factors that are needed to have full access to those resources. The next one we'll look at is the principle of least privilege. And in simple terms, that is granting minimum permissions necessary for users to perform their jobs. So this reduces the potential attack surface and limits the impact of compromised accounts. This practice ensures that users can only access and modify resources essential for their roles, minimizing the risk of unintended data exposure or modifications. So with principle of least privilege, you ensure that each account or each user is limited in what they can do. Limited in the sense that only their essential functions and roles can be performed with those accounts. So in the unfortunate instance of an attacker gaining access, unauthorized access to one account, he would not have access to everything else. He'll be limited in the damage that he can perform because each account is limited to what the user is supposed to do. The last one we'll look at is regular audits and monitoring. And this is ensuring identities and permissions are up to date and secure. So with the continuous monitoring of user activity, access logs, and configurations, this will help us to detect and respond to security incidents promptly. Auditing user permissions ensures that they align with current roles and responsibilities whilst monitoring for unusual activities. And this helps to identify potential security threats or unauthorized access attempts early. So usually when you try to log into a service or perform any task, it's usually logged. So there's always a record of which user is doing this and what the person is trying to do. So if you notice at maybe work ends at 5 p.m., but at 10 p.m., you can notice that there's a user who has repeatedly tried to access an account or a resource within your cloud or within your system. Now you can then notice that there might be something strange going on. Someone might be trying to breach your system because it's an unusual activity at that time, and you are able to trace it because there's record of the things that happen on your system. So implementing these best practices ensures that organizations can maintain a secure and compliant AWS environment, safeguard sensitive data, and also mitigate risks effectively. By integrating these principles into their identity management strategy, businesses can enhance operational resilience and maintain trust with stakeholders whilst leveraging the scalability and flexibility of AWS services. Could you please move to the next slide for me? All right, so this brings us to the end of our presentation, and I'll give a brief summary of what we have gone through. Through this presentation, we have explored the critical role of identity management in ensuring robust security measures within AWS environment. We mentioned that identity management encompasses the essential principles, the AAA of authentication, authorization, and accounting, which form the foundation for secure access control and resource protection. So we also know that the components of identity management, the authentication mechanisms, and the more fine-grained authorization controls. We discussed how AWS provides a comprehensive suite of tools and services like the IAM, the SSO, and the managed directory services to facilitate effective identity management practices. We also explored the best practices, multi-factor authentication, adhering to the principle of least privilege, and conducting regular audits and monitoring to detect security threats, promptly. In conclusion, effective identity management in AWS is not just about managing user credentials, but it's also about leveraging secure authentication methods, implementing precise authorization controls, and maintaining comprehensive audit trails. By integrating these practices and leveraging AWS robust management services, organizations can protect their valuable assets and ensure compliance with regulatory requirements and also mitigate security risks effectively within the cloud. Thank you. This brings us to the end of our presentation, and any questions are welcome.
Great. So, Mr. Eddie, I just want to so I just wanted to add some few and then just some few additions, and that's it. if I'm permitted. Madam
Yes.
Akosia, please, am I permitted?
Yeah, you're permitted.
Hello, madam. Okay, madam. Thank you very much. So I wanted to add like more on the password managers and also like the best practices. So yeah, so like last time I remember, I mean the initial stages of the course, there's especially security. Mr. Dennis and other members in the group other members on the broadcast were talking about password managers and a whole lot of and organizations or software, companies that come up with, this password. They keep your passwords, very, very. So like I said, so he was talking about the MFA. So like we have to bear in mind that right now, what a lot of top-notch companies are using, software companies are using for their authentication is the two-factor authentication. And I wanted to just throw some small light on it. So one thing I realized is that the two-factor authentication is no more safe. It's no more safe in this, era, or in 2024. It's no more safe for, for login. So I just came across just some few days ago, I just came across a hack, a hack tip that you can use to, hack someone's Gmail. And the process was very simple, was very, very simple. The process was very simple. And also, I wanted to also talk about, so meaning that if we are, I believe some of us are also, we are into software development as well. So going forward, if we can also make the system very rigid, especially in the login aspect, because honestly, two-factor authentication is no more safe. Two-factor authentication is no more safe. So like you said, the multi-factor authentication, whereby you have sorry.
Sorry, go ahead.
Okay, so whereby you have the passphrase, and also you can enter either your PIN code or add any sort of validation, which is the who you are. Maybe your fingerprints or maybe your facial recognition. So these things are all can be achieved. And also talking about the password managers too, like I wanted to throw some brief light on it. So sometimes maybe you are creating an account and maybe you're in a hurry. So imagine maybe you're not using Google Chrome, whereby it's going to provide you the password managers. So meaning you're just going to enter, just a random, maybe just let me in, or password 123. Yeah, that's what most of us grew up with, especially we had a lot of Gmail accounts and we just put in that short password so we can remember. So what's happening is that right now there is a spyware called dictionary attack, whereby people can just automate. Maybe if your password is maybe Daniel Sorry 123, there is a dictionary or something that can and they just automate it on your system, and it just runs through anywhere it finds. If truly your password was originated from a dictionary, or maybe your password is just Daniel or my name is, it can just automatically log the person in. And also I wanted to talk also about the rainbow data. What's the name? Please, if you can remind the rainbow data attack. Hello, Madam Agosia. Hello, Madam.
I think you are going
Yes,
to say
hello.
table attack.
You said
Yes, I wanted
rainbow.
to add the rainbow table attack.
Rainbow table attack.
So yes, a malware whereby like the hash they use especially sometimes when you set up a database and maybe you put, maybe the username is Daniel and the password is maybe Asari. It's encrypted for you using either Argon or any of the hash encryption.
Yeah.
Yes, please. So I even saw it in a slide.
Yeah, so what
Yeah,
Yeah,
they're
please. The name is
hashing that so
you are
Rainbow Table
correct.
Attack.
Yes,
yeah.
correct.
Okay.
Rainbow table attack,
Okay.
correct.
Yeah. I just wanted to, I wasn't very sure about it. Thank you very much for the confirmation. So in that instance, when maybe most of us that work a lot with the database, sometimes, like I said, you create, a password which is, very short, maybe password 123, and it provides a hash, key or strings, or just some hash strings. When they run this rainbow table attack, it's able to, it's a whole lot of hash keys That, I mean, so it has a lot of hash keys, a lot of them. So it will just make sure that which hash, I don't know if you guys are getting me, like, you know, when you enter your password, it will convert it into a hash key, I don't know, with a database, those who are familiar with it. So they have a system that when they run, which is the rainbow table attack, it will just, I mean, search through their database and find out exactly which hash key fits or matches with it. Then once it matches with it, they automatically log themselves in. And also, I wanted to touch lastly on this one. I realized, I know I knew about it, but I just wanted to put it. So sometimes some of the code we use, sometimes we can be hacked through it. I don't know if anyone knows about it. Sometimes some of the USB code we use, it can be hacked. So I think 4 years ago or 5 years ago, Kelvin Mitnick did an interview, and he brought in 2 laptops, and he brought in a code, and the code, when he inserted the code into the laptop, and I mean to his phone or something, the code was able to run some scripts. Once he inserted into it, they had a malware installed on the code. So when he just placed the code in the PC, it was able to run some scripts, and that was it. The malware was installed. And once the malware was installed, he was able to have remote access. So on the other side of his PC, so it was 2 PCs. So on the other side of it, he was able to see exactly what you are doing on your PC. He can turn on the mic, he can have access to the camera, a whole lot of things, and confidential stuff on your PC, he can just access it. So I just wanted us to draw our mind on some of these things. Sometimes you have to purchase things from, I mean, I'm not saying Apple is trusted or Nokia or Samsung or product is trusted, but sometimes you have to purchase our stuff from these, I mean, trusted, I mean, shops, where maybe Apple Store or iStore, where like it has been certified. Now, okay, this Samsung store. Because trust me, we being IT guys, there are going to be some instance whereby confidential data is going to be handed to us. And imagine that then that scenario, and I just went to check, or I went to La Paz and I'm searching for a code, and I just bought a normal code. Trust me, you wouldn't know who is, I mean, hacking into your system. So it's just, I mean, a light I just wanted to, I mean, just a brief thing I just wanted to see about the best practices. All right, thank you very much.
Thank you very much, Daniel. That's really great, and it's also a good trait to be looking out for these updates in tech, especially concerning security and then other areas. And thank you for sharing all of that with us. Please, are there any questions for group 1? Okay. So it was a really good presentation, and I really liked the way your slides were, and the whole bringing it to real life scenarios too. You had a lot of that, which is also really good. So just to recap what group 1 has said, it's about the access that we grant to users inside of so are we providing the right level of access to the resources they need? We've spoken about least privilege, so you give people exactly the permissions that they need. You don't give them anything more. And we looked at the ways that you can secure, or the kind of measures that you can use to secure your access. He also mentioned MFA. So when you create an AWS account, for instance, it's encouraged for you to have an another way to authenticate you. So aside that email and password that you provide, probably could be your phone number. You could use the Google or Microsoft Authenticator app, and it could also be your mail. Asari mentioned how the mail was not so reliable now because people could hack and things like that. But that's it on MFA. And inside AWS, your identity management solution for best practice is to implement these the policies, the users, and then the rules, and making sure that people have access to exactly what they need to have access to. And we also mentioned password policies. Sometimes we would be logging in, sorry, we'll be creating an account with a site or a company, and then they would ask us input one small letter, input at least one capital letter, input. So all these things also help to mitigate these security attacks because, for example, with the dictionary attack that Asari spoke about, imagine your password is just a word in the dictionary. The dictionary attack inputs all the words inside the dictionary. So it's like a trial and error thing. So it tries all the words. So if your password is just a word in the dictionary, then definitely they would be able to get you. Another thing he mentioned too was about the hashing. So in Linux, for instance, with the Linux class that we had, any password that you set, it would hash it and then store it in a file on your server. So if my password is, for example, factor, and I hash it, and somebody else's password is also factor, and she hashes it, the value, so hash is like, let's say, making that word factor, making it unreadable. So it's kind of like a way of encryption, but this is more one way. So whatever the other person's hash value would be, if the person and I, we have the same password, then it's going to be the same hash value that we have. So the rainbow table attack spoke about is when the hash values have been, they try all different hash values and then to guess or to kind of guess your password. So it's more like trial and error, but then they have like really advanced systems that can like go through like the whole list and try to get whatever password it is for you. And that's why single sign-on tool is encouraged because I think some of us have seen. So sometimes when we try to log into Facebook or some other sites, we can see an option where you want to use your Gmail to log in through. So it's like, do you want to go through Google? Or sometimes you can use your Facebook account to log in into some other account. So this is like federated access, okay? So Facebook is or Google is telling Facebook that, okay, we know this person and we trust this person. So you give permissions to Facebook to access your Google account. So they would also ask you to confirm, okay, this is the level of access we are giving this person that you want us to federate. Victoria.
This is a mistake.
Oh, okay. All right, so Dennis was also spoken about password managers before. A lot of the time you need to probably create a new password or something to be able to sign in or sign up for an account. So the passwords get a lot. So it's also good to use trusted password managers to manage your passwords because remembering like a lot of password gets a lot and then it leaves like more room or more chances for you to get an attack. All right, so I believe we can, if there are no further questions, we can end today's session, and tomorrow morning we meet for identity and access management in AWS.
Thank you.
What's his name? Did Janin participate in the assignment? William?
Yeah,
Yeah, did you hear from Janin during the assignment?
Janin.
Emmanuel
Yeah,
Channing.
Emmanuel,
yeah,
yeah.
Yes.
he had some emergency at work, so he wouldn't be able to present.
Yes, to present. But he participated. He really helped us with the presentation as well.
Yeah, he was there during the discussion.
Okay. Thank you. Gifty.
Hello, Africa.
Hi.
Please, I wanted to ask of using Apple.
Yeah, I reached out to him, but he hasn't responded. So I wasn't seeing him in class for a while. So I think last week I reached out to him, but then he hasn't responded yet.
Thank you.
Okay, if that's so, I'll see you guys tomorrow.
All right, take care.
Yeah, and
Thank
Agosia,
you.
please, can I add one thing?
Go ahead, Daniel.
Yes, please. So I just wanted to just bring it for us to all discuss about it. Because please, one thing I've realized is that especially most programs being organized in Ghana here, even if tech programs or like most programs being organized here, I realize that cybersecurity is none of this country's business. That's one thing I've realized. So yeah, please. It's true. Like, recently, my technical lead, my boss was supposed to have a meeting to but we have called IT guys, some IT guys for a meeting at Lapan. But my boss wasn't able to make it. It was my technical lead that was, asked to go there and go and have the meeting. And we were present over there. And what they were all talking about was just data decentralization, sorry, like how we can have access to the public data and a whole lot. There was nothing about cybersecurity, nothing about how to protect our data, and most tech companies, most tech programs, tech in Ghana, when you go, the same thing, when you go to GDIW, they'll be doing it very soon. GDIW, I've been to 2022, 2023, there is nothing
like you.
And I just don't know if.
What time? I'm closing.
Okay. Okay, fine.
When I'm done.
Yeah, we can hear you.
Okay.
We can hear you.
We are still recording.
Oh, technology reveals everything.
Hi, Daniel.
Please.
Please, what happened? So like my sound went off for a short while.
We just love the way you are whispering.
we had what?
You're whispering. I thought you were talking to me.
Is that guest star with
Oh, sorry about that. Daniel, so I don't really know the details of the assertion that you made, but there's a company that I used to work for. So what they do is they train cybersecurity analysts, but that was really banking related. So it was BOG that was kind of like heading the whole process. But then I know all banks in Ghana were involved. So there is like provision for that, but I don't really know the details of it.
The details. Okay. So because one thing that I came across with the bank, they to like more of like blockchain. So how to use Ethereum. So something like MasterCard,